Hi guys, Assalamu alaikum. This is Arif. In this video, we are going to see how we can give delays or add delays to signals. I mean multiple signals. And we are going to specifically see in this video how we can add multiple delays, like more than one delay to a signal. Like if you want to give one logic to a signal by giving it a delay, and then you are going to again delay for some time and give then the logic 0 to that signal. So how we can do that? And first we are going to do that in a system Verilog program and then in a VHDL program. So this is a system Verilog program first, and its module name is project. It has clock, PC, reset, 3 inputs, and there are 4 output signals: ALU logic, load logic, store logic, and branch logic. And here we have defined here these inputs and outputs. And after that, in our main block, which is always block, we are saying we are giving it the sensitivity list of PC and reset. And after that, at the beginning, we are just converting this PC, which is going to be 11 bits, into an integer. And after that, what we are going to do is we are going to say that if reset is equal to 1, then all these outputs are going to be zeros. And after that, we are going to say else if reset is equal to 0, then we are going to say check these PC values, and if those are less than 500, that means those have the ALU logic we are going to implement. And if those are between 504 to 600, we are going to implement the load logic. And if those are between 604 to 700, we are going to implement the store logic. And else if those are above 700, we are going to implement the branch logic. So with this is the output. We are giving it a 1 without a delay, but here we are going to give the signal a delay of 20 nanoseconds, and the rest of the other signals are going to be zeros, because here we are going to implement the ALU logic. So we are just making it 1 after a delay of 20 nanoseconds. After that, we are going to give this load logic a 1 after 40 nanoseconds, just a random delay. And after that, we are going to give this store logic 1 after 60 nanoseconds, and then the branch logic 80 nanoseconds. These are just random delays, and this way we can actually add a delay to this signal. Like this line is without delay, this line is with delay. So let's run this program so that you can see actually those delays. And before that, actually I can show you the Testbench as well. So this is just a Testbench program, so in which this is the test project is its module name, and then we have given these inputs as rec, you can see, and outputs as wire. And here we are calling that module our project, which is our main program in the Testbench. Same inputs and outputs we are giving. And after that, in the initial block, we are defining a clock which is of 20 nanoseconds, like this. And then we are saying actually that PC is going to have some values, and like for example, this is the value of the PC once we have a reset equal to 1. So it is not going to do anything. And after the 100 nanoseconds delay, we are going to say PC is going to be the value of our ALU logic, and then the PC is going to be 512, which is going to be of the load logic, and then the store logic, and then the branch logic. So just 4 values, and then we are going to make the reset is equal to 1 again. Right here our resets are 0, you can see, with the 100 nanoseconds delay. So this is the Testbench, and accordingly we are going to see the outputs as well on the screen. So you guys can see that this first logic, it is getting delayed by 1 clock cycle, this by 2. The clock cycle is 20 nanoseconds, and here it is getting the 20 nanoseconds delay, here it is 40 nanoseconds delay, here it is 60 nanoseconds delay. The way we gave these delays to our output signals, and it is going to get 80 nanoseconds, you see. And here the reset is going to be 0 again, 1 again, and here reset is 1, and then once the reset is 0, we are getting these outputs. So here we are just giving a single delay to our signal. Now we are going to give it a second delay, and in order to do that, what we are going to do is we are going to just add some new lines to the code. So we are going to add this line. We are going to say, okay, make it a 1 after 20 nanoseconds, make it a 0 after 40 nanoseconds, right? So multiple delays we are going to give, and then we are going to say, okay, this signal also make it a 1 after 40 nanoseconds and make it a 0 again after 60 nanoseconds. And then we are going to say here again, that make it a 1 after 60 nanoseconds and 0 after 80 nanoseconds. And here again we can add another delay, so make it a 0 after 100 nanoseconds, right? So this is the way actually we can give multiple delays to a signal, and here we are actually delaying our output like this. So let's save this program. Compile this program and then now run this program. So now you guys can see that it is getting a 1 after 1 cycle, and after the second cycle after 40 nanoseconds we are saying make it a 0, and here it is getting a 1 after 40 nanoseconds, and we are saying after 60 nanoseconds make it a 0. Same with these things. So this is the way we can add multiple delays, and this is the way we are going to see our output. And in the case of both Verilog and VHDL programs, you guys can see that these sensitivity lists in these blocks are really important. So in this always block we are giving it a PC or a reset, but if we are going to add this one, a star, which is going to give it all inputs like PC, reset and clock, right, in the sensitivity list. So this is the way we can also modify this code and we can get the same outputs. But if you guys are going to try these two always blocks, like with this sensitivity list of clock or clock and reset, these are not going to work. You guys can try at your end, but only these two are going to work, sensitivity lists. So always check your sensitivity list once you guys are going to add delays and you guys are not going to get those outputs which you guys were looking for. So always come up here and try to do something different. You are going to see the right output, because many times the sensitivity list is not good. But I can just show you the output with this as well. The logic changes once you guys change the sensitivity list. So in the case of delays, this is really important. and you guys can see the same output. Now let's close this program and go towards the VHDL program and see how we can add the multiple delays to a VHDL program now. So let's close these two windows and open these two VHDL files. So first go here into our main program, and this is our libraries, first three libraries, and then we have the entity project, same name, and then we have the three inputs, clock, PC reset, and these are the four outputs. This is the way we define our inputs and outputs in a VHDL program. And then in the architecture we are going to say that look, we are giving here in this process block this reset and PC in the sensitivity list, similar things, right? And then after that we are going to come here, and what we are going to do is we are going to convert first of all our PC which is in the bits into an integer, and after that we are going to say if reset is equal to 1, then make all these outputs equal to 0, else clock tick event and clock is equal to 1. Then what we are going to do, we are going to say again check the PC values, and if those are between 500, implement the ALU logic, you see, and delay it after 20 nanoseconds. So this is the line without a delay, right? And this is the line with a 20 nanoseconds delay output. And after that we are going to say if the PC is between 504 to 600, then implement this load logic, and but it is going to get delayed after 40 nanoseconds, right? And then we are going to say if PC is going to be 604 to 700, implement the store logic and make it a 1, and then give this after this much delay 16 nanoseconds, make all the other outputs equal to 0, and then else if it is above 700, then it is branch logic, and then we are going to say okay, delay this signal for 80 nanoseconds and make it a 1, and all the other signals are going to be 0. This is the way we can give our signal a single delay and give it a logic value, right? So let's go towards the test bench as well. Test bench is going to be on the similar pattern. So first two libraries, and then we are going to say, so first two libraries, and then we are going to say entity test project, and here is the architecture. In this we are going to use this project entity as a component and same input and outputs, and then after that we are going to define these signals which are going to be our input and outputs, and then beginning of the architecture, and here we are going to call that same entity project, and here we are going to port map its inputs and outputs like this, and then we are going to start this process block, and here we are going to actually give it a clock, and clock is going to be of 20 nanoseconds, and end process, and then we are going to go to our second process, and we are going to say give the PC this value, but reset is going to be 1, so nothing is going to be happen, and wait for 100 nanoseconds, then make this PC value like this, and since this is a ALU logic, and then we are going to make this reset equal to 0, and then for the load logic we are going to give this PC a value like this, above 500 and below 600, and wait for 100 nanoseconds, and then store. We are going to give this PC a value, according to the store logic, and then we are going to give the PC above the 700 for the branch logic, and then we are going to say whatever is the PC, make reset equal to 1. So this is the same test bench on the same pattern which we used for the Verilog program. You guys are going to see the same outputs, but let me run this program. So now you guys can see this signal is getting a delay of 1 clock cycle, 20 nanoseconds, this 40 nanoseconds, this 60 nanoseconds, and this 80 nanoseconds, right? And then it is becoming a 1. These all are becoming 1 after some delays. And now we are going to see how we can add multiple delays, right? And after this much delay, we are making it a 1, but after some more delay, we are going to make it a 0 now as well. So skip out this line and this include this line. This is the way actually we can give multiple delays to a signal. You see, make it a 1 after 20 nanoseconds, but make it a 0 comma, make it a 0 after 40 nanoseconds, right? And then we are going to make it again like this and include this line. Now load logic, we are going to say make it a 1 after 40 nanoseconds, make it a 0 after 60 nanoseconds. This is the way we can add the multiple delays and make our logic a 1 or a 0. So store logic, make it a 1 after 60 nanoseconds, comma, make it a 0 after 80 nanoseconds. And then the branch logic as well, we are going to skip out this line and we are going to include this line. And now we are going to say make it a 1 after 80 nanoseconds, make it a 0 after 5 into 20, 100 nanoseconds. So this is the way we are going to modify our code. So let's compile this program. Let's double check if I have included all the lines. Yes. So the multiple delays each signal is getting. And now let's simulate this and see if we can see the same outputs the way we saw in our Verilog program. So you guys can see the similar output. So it is getting a 20 nanoseconds delay, making it a 1. After that, after 40 nanoseconds, 0. 40 nanoseconds delay, making it a 1 after that, and then after 60 nanoseconds, 0. So this is the same output, and then we are going to reset. So all the outputs are going to be 0. But again, as I told you, that this line or these delays won't work if your sensitivity list is not right. So let's go to its sensitivity list and check how we have defined. You see, here I am giving it a reset and a PC in the sensitivity list. This is an input, this is an input. This is the way it is going to work. All the other ways it is not going to work. You can try even this all as well. So that's why I told you already that if your signal delays are not working as you expect, always come here and check its sensitivity list, because for sensitivity lists delays are going to work if your sensitivity list is properly selected. but otherwise this line won't even work. I can tell you this after 2 afters, like you can see here. So thank you guys. I hope you guys have enjoyed this video. Have fun.